Today we're going to be calculating the area of composite shapes. So the area is the bit inside the shape as opposed to the perimeter that we were looking at last lesson, which is the bit around the shape. We're going to be using a combination of formulas because the composite shapes can be made up of multiple more basic shapes, and we need to make sure our units are the same before starting, or else we might end up with an incorrect answer. So for this shape below, I've got, I can see I've got some semicircles and a square. And I'm going to come up with a formula on how I can calculate the total area of this shape. Now, if I put two semicircles together, it turns into a whole circle. So I've really got two full circles made up of these bits. And then I've got a square. And if I look at my formula sheet, the area for circles is pi r squared, and the area for a square is L squared. So now I need to find what the value of my L, or my length, is, and the value of my radius is. So my length is actually labelled for me. That's just 2 millimeters. My radius is going to be half of that length, because the radius is the bit that sits on the circumference of the circle to the center point. So my radius is 1 millimeter. Next, I'm going to substitute those into my equation or my formula. Oops, this is one. Be careful that you substitute the correct bits where they need to go. And 2 times pi times 1 squared gives me 2 pi, and this bit here is going to give me 4. Now, if you were asked to leave this answer in exact form or in surd form, you would leave it like this. And that's because pi is an irrational number. If we were asked to find what this the area of this shape was correct to 2 decimal places, then we would evaluate that on our calculator, and it would be approximately 10.28, and we need to include our units, millimeters squared, because it's area. Okay, let's have a go at this shape. Now, we have to round to 2 decimal places for this question, but I'm also looking at this shape and I'm going, it doesn't look very familiar to me at all. So when you get a question that doesn't look very familiar, try and think about how we could rearrange the shape so it does look more familiar. And if I took this bit here, you can see that it's kind of like a semicircle and that it fits exactly in there. And so what I end up with is a semicircle with a diameter of 8 centimeters. And now I can create a formula. So area is going to equal pi r squared, which is my circle formula, divided by 2, because I only want half of it. And my radius is going to be, so this is my diameter, that full length. So my radius is 4 pi times 4 squared divided by 2. And when I put that in my calculator, I get 25.13 centimeters squared. Okay, one more before I get you to go off and have a shot at this yourself. So this time we're finding the area of the shaded part of the shape. So this bit here, and they want our answer to the nearest whole number. Okay, so it's going to involve circles, but let's have a think about how we can access that shaded part of the shape. So my area of my shaded part is going to equal, let's take the area of the big circle and if I then subtract the area of the little circle, then we're going to be left with that shaded part, so that's good. Okay, so the radius, let's have a think about this, because my area of a circle formula is pi r squared. So my big radius, I'm going to call R1, is 15 centimeters, and my little circle radius is 8 centimeters. So if you've got two radius or two values that are representing the same descriptive thing, you can just use these little subscripts to differentiate between the two. So my area of my big circle, pi r1 squared, minus the area of the little circle, so pi r2 squared. Substituting in. And what I'm going to get, remembering we're rounding to the nearest whole number, is 506 centimeters squared.